Hello everyone. Today we are going to present on Apple Smart Database. Myself is Fanil Patel and my group member are Adam Gordon and Sarah Merck. Introduction. This project is focused on creating a powerful integrated database system for Apple. The reason is why. This database helps us to track Apple's customers, employees, and products that can enhance Apple's operational efficiency. Our goal is to enhance operational efficiency in Apple by creating a functional database that allows management to develop insights into customer behavior, product performance, and employee roles, and also helps in making strategic decisions that respond to the target market, invest in profitable technologies, and control company budget across departments. Now, the main goal of this database. Now let's talk about what this database is designed to achieve. We aim to answer critical business questions for Apple through this main goal. The first goal is to identify top customer spending over $500 to optimize sales strategies. The second is to calculate average price for Apple's product catalog like iPhone and MacBook to make decisions supporting the market's willingness to pay. The third one is to analyze department-wise employee distribution to enhance operational efficiency. The fourth one is to track subscription trends for Apple Music, Apple TV Plus, and other services to drive growth. And the last one is to evaluate payment method referencing Apple to measure brand impact and visibility. Now the Apple's business domain. Apple's business domain depends on six key departments working together smoothly. Here is how they contribute. Product department, product development, creating amazing product like iPhone and MacBook. Sales department includes making sure that their customer have the best buying experience. Relation Customer relation includes building loyalty through personalized support. The role of HR is to manage Apple's talented workforce. Supply chain. The duty of supply chain is to ensure products are delivered on time and worldwide. Marketing. Marketing's role is to strengthen Apple's brand and connecting with its audience. Now, entities and relationship. Here is the backbone of our database, the entities and the relationship. These define how our data is organized and connected. We have 10 main entities for our database: products, orders, subscription types, customers, payments, suppliers, inventory, marketing, campaign, employee, and department. Relationship. Products and orders have many-to-many relationship because an order can include multiple products and a product can appear in multiple order. Employees manage department and marketing campaign are tied to products. Customers are linked to both orders and subscription services. Now the problem and solution. We notice some challenges with our many-to-many relationship like between products and order or orders and subscription type. This relationship could cause redundancy and making our database less efficient. To ensure this in our dataset is in third normal form, we fix this relationship by breaking them into two new entities, namely customer and subscription services. And this process is called normalization, which helps in organizing the data better. Now, the foreign key placement in one-to-one relationship rule. In this database, orders and payments have one-to-one relationship. Each order is paid in full of a single payment, so we need a way to link these two entities effectively. So we choose to store payment ID as a foreign key in the order entity so that we can track payment for orders, customers, and product. Now the further presentation will be continued by my group mate Sarah.
So in this slide, you can see our hand-drawn ERD that shows the relationships, the many-to-many relationships with orders, and also our many-to-many relationships with subscription types. In this, you can see where we broke the relationships and where we placed our foreign keys to keep our ERD in third normal form. We have department and employee tables that have no relationship to the sales process, but we still included them for our business purposes. In our next slide, it's going to explain the user defined constraints that we included in our ERD. So, to ensure that the relationships that we had matched our business scenario to prevent having multiple many to many relationships, we have one employee can belong to one department, only one supplier per product, and only one product per marketing campaign. The next slide shows our relational schema where the foreign keys point to the primary keys for our ERD in this slide. The next slide begins our SQL coding where we started with the product table because it's the one that did not have a foreign key. And then we slowly added the foreign keys after. So we started with product, then marketing campaign, table customer, and then department. And we did our varchars and our numeric keys to match as well so they fit in our table. The next slide references the foreign keys to achieve info later. So we have our table that's service, we have our payment table, we have inventory, and we have employee. And you can see where we included our foreign keys in the inventory and also in the employee table. And then subscription and orders were formed from breaking the many to many relationships. And subscription has a composite primary key. Order does not have a preference. And then this is the ERD output where our hand-drawn one versus the one that we created in the SQL database, where we can see that employee and department still do not have a relationship or are not connected to the database, but they were important for our presentation and our business scenario. Next is the insert tables and their results that Aiden will explain.
All right, my dog is active upstairs, so I don't know how long I got, but oh. I wanted to display the hand-drawn ERD that we have. Um, this is in comparison to what you see on the screen right now. We did it in pen. Sarah is not a pen girl, but she used my pen and it looks really good. We listed out the order that the tables needed to be in for us to code, so that there weren't any reference errors when we inserted all of the data that Vanil created for us. So thanks to him. Um, this is the data that I'm talking about. Um, we did run into some errors, but that's because our O's were zeros sometimes. Um, but basically we gave them alphanumeric primary keys. And then the date was something that we had to figure out. It's hard to do date in Python, and we'd rather code dates in something like Oracle or something else. Um, we ran into a problem when we did monthly revenue because it couldn't handle this many characters or something, or we didn't know the data type needed to be, I think it was numeric. I don't know. Um, yeah, everything turned out right. So now we can retrieve information from this data. Um, so we want to know who had an order that was over $500 so that we can keep relying on them to buy our most expensive products. We could put them in their own group and monitor them through this table. The next one, we did a formula for average price of all of the products in Apple's catalog. Um, this is just Apple saying on average, how much are our customers going to spend per order if they're ordering all of our products. This one is another simple query where we use like to find payments made using Apple payment methods. So it's Apple Pay. And this is monitoring the brand loyalty, which is one of our main goals of making this database to see which customers live and breathe Apple. Now we're getting more advanced queries, and that's where we have information from joining two tables. So we want to join the department and the employee table to see the number of employees in each job role, because job role is part of department, I think. Or maybe it isn't. The number of employees is a part of the department, and job role is a part of the employee. So to join, we joined on department ID here, because that's in both. The next one, we want to get information on customers that subscribed in 2024. We want to retain our new customers. So this database pulls where they're from and what kind of customer segment they are. Maybe we could find that there's a lot more individual than business customer segments, and we want to push on business next year. Oh, there's Charlie again. Last advanced query, we wanted to do something very similar, pulling the new customers, but then if you wanted to search them by name, you could do that too and see the date that they joined. So in conclusion, using our alphanumeric 3-digit primary keys, then there's 46,000 possible combinations. That means that many products can be sold, that many orders, and so forth. So this model needs to be scaled, and you need a team to work on it to handle all the different types of data that are going to come in. And if you wanted to build this, you need to hire us because we built it, and it would be an easy fix, but we would need a full year's pay to work on it after we finish in Chattanooga, of course, because we can't get tied up. We've got a lot going on. Okay. So what we learned, this project taught us to determine our favorite company. Fanil came up with Apple, and that's a good choice. And their business entities, he came up with all of the entities and how they're related to each other. Then we learned how to design their relationships in an ERD, which we learned in this class. And then code this in MySQL Server. And then we used SQL language to retrieve information from our database. And this helps Apple in their decision making and will improve their business. We don't have a next slide. Let's see. I'm gonna do this right here. So I can make it full screen for us. There we go. One take.
I hope you enjoyed our presentation.
We did it in one.
Yeah, we did that.
All right, let me